Okay, here's your review for the final standard, standard 5. Okay. Polynomial equations and functions. Now, I have a multiplication chart because there's going to be some factoring, and I've also got another sheet that has a discriminant on it, okay, which is helpful later. Okay, so first thing, and I'm going to be illustrating some points on this green sheet, this blank green sheet you don't have to write anything on. Find the function graph's end behavior. Okay, means if that was put on a graph, what would it end up as we get further out? Would it be going up or down, and then would it be going up or down over there? That's what that negative, positive infinity, negative infinity means. Now, two things I have to know to identify the end behaviors. I need to know the leading coefficient, and I also need then to know the degree. Leading coefficient here would be a 1, so it's positive 1. Because that's positive, then y, as x goes this way, my y goes up. So that's positive infinity. Okay. Okay, the degree is the highest exponent. It's 8. Now, is that even or odd? That's even. So if the highest exponent's even, the end behaviors have to match. Okay, so if that's positive infinity, this has to be positive infinity. So they'd both be going up. Okay, it'd be a crazy graph, but in the end they both go up. Okay, number 2, y equals negative 1x to the 7th minus 3x to the 5th minus 5x to the 3rd. Okay, and as you can see, these are ordered properly: 8th power, 4th power, 2nd power, 7th, 5, 3. It's got to go from highest to lowest. Okay, so leading coefficient is negative 1, and the degree. So if the leading coefficient is negative, then my y is going to approach negative infinity. As x goes out this way, then I'm going to get a graph that just goes down. The degree is 7. Now that's odd, so that is a mismatch. That means I need to switch the end behavior here to positive. That means as you go out here, you're going to get a graph that goes up. It's going to go up, and then as I go, it goes down. Okay. Now, number 3, you got a little issue. First off, it's hard. You don't know your leading coefficient because this is out of order. Okay. So your highest power is a 4, but you got 2 of them. So you need to combine those. You need to add negative 1 plus negative 7 plus negative 1. That's negative 8x to the 4th. Then I don't have any x to the 3rds, then the 3x to the 2nd, and then the plus 9. Now you're good, okay? X 4th, x 2nd, constant. So leading coefficient, you can abbreviate that if you want, and then degree. Leading coefficient's negative 8, so we have a negative, so that means it goes negative infinity this way, okay? Be just going down. Now, if I go out the other way, it depends on the degree. The degree is 4. It's a 4th power. That's even, so that's going to be a match. Okay? So they have to match in end behavior. They'd both be going down and going down. Okay, that's end behavior. Now, next thing. Read the directions carefully. Write a polynomial function given each of the roots. Only real rational values need to appear in the equation. Here's what that means. They can't have i's, they can't have square roots in the end answer. Now, so you write y equals, and these are all real numbers, okay? I don't see I don't see any square roots, so they're all real, okay? So, and rational. X minus and then 1. And these do not get pairs, okay? They don't come in pairs when they're real and rational. Minus 2, x minus, but if it's a negative, it goes plus. Easy enough there. Now it gets a little harder. Now, this is an irrational number, okay? Those come in pairs, so I put negative square root of 2. That's an imaginary because of the I, okay? Those come in pairs, so 3i. So that's 4 roots I need to start out with. x minus, I'll do that one first, and I switch it to plus square root of 2. X minus, and then I just put square root of 2. X minus, and I put 3i. X minus, then I make that positive 3i. But you need to take it a step further, because that's what this, only real rational values need to appear in the equation, okay? So, I'm going to do the FOIL method. I'm going to combine these into one parentheses and combine those into one. There is a quick way, but many of you may not remember it, okay? So if I FOIL, and just watch me do it, because there's a quicker way to get what's in there. I go x times x times negative square root 2, square root 2 times x, and then square root 2 times negative square root 2. So that's x second, that's negative square root of 2x, that's positive square root of 2x, bye-bye. So I've got a negative and a positive of the same thing. This is going to be negative square root, and since the 2's are both in square roots, I multiply them, and that's 4. But what is the square root of 4 actually? Look on the board. It's 2, okay? So this is really negative 2. So x squared minus 2. Now, here's the rule for that. You can take your x times your x squared. And then it always is minus, because a positive times a negative is negative. And then the square roots just go away, and I just have a whole number 2. Now, let's remember how to do the i's, okay? So, x times x, that'd be x times 3i, negative 3i times x, and then negative 3i times 3i. X second, 3ix, negative 3ix, see ya. That's negative 9i to the second, but I to the second's really negative 1, so that ends up as 9. So this is x squared plus 9. Now let's discover how we can get that quicker. Well, I can take the x times the x, and unlike here where it's a minus, we're going to have a plus, because remember, I squared changes it over, so it's plus, and then I just take 3 times 3 and forget about the i's, 9. Okay, so this is a final answer. Now I only have rational numbers and no i's. Okay, next one, y equals. Now 6 is a rational, it doesn't have a square root, doesn't have an I, so it does not have a pair. Okay, this would have a pair of the opposite, and this would have a pair of the opposite. So we got x minus 6, easy enough. Then I go into my pairs. X minus, and then plus square root of 3. X minus, and then square root of 3. X minus, and then 1i, and then x plus 1i. Now let's use this to find our little tricks, okay? This x minus 6, these get combined, and so do these. So that's x minus 6. Now remember how I can quickly combine them. X to the second, positive times a negative is a negative, okay? And that would just become 3 whole, because square root of 9 is 3. Over here, x second, and remember, this switches to plus, because remember what the I to the second does. Negative 1 times positive 1 is negative 1, but I to the second will make it positive 1, okay? And that's good enough right there. Okay, now, the next one. Find all roots in the equation by factoring. I just need to see some boxes. There are 3 roots because it's x to the third. You have a trinomial. You're already equal to 0, so you do your GCF table. Now you got to be looking after you're done with your parentheses here. Okay, the GCF, it'd be 1, but they all have x. I see x on the last line, so it's 1x. So I actually have to do it, okay? Okay, this now goes to 1x to the second when you're dividing, minus 7x minus 18. Now take that 1x that's out there, and you're going to get your first root using that. Divide by 1, and that's 0. You just take this here, the outside, 0. Now, ABC. So 1 times negative 18 is negative 18. So that's a positive times a negative, and we're adding to try to make negative 7. 1 and 18, that's negative 17. Divide by 2, you get 9. Bingo. Now, pay attention to what your A is. Your A is 1 with an x squared attached. You can get rid of the 1, okay? And you split your x second just like before. If it's x to the 4th, then it goes x second, okay? X second, okay? Or no, that's x, my bad. X second, we go x. If it's x 4th, we go x second. So plus 2 minus 9. Now, I don't have to do anything more because these x's no longer have even powers on them, okay? So set each factor equal to 0, and you get your other 2 roots. Sorry, I kind of messed that explanation up. So negative 2, positive 9. There you go, 3 roots. Okay, number 8. There are 4 roots because of the 4th power. Your 0's there, and you have 3 terms again. So greatest common factor, and then my table. Okay, 1, 10, and 9 would just have a 1, and there's not an x on this 9. The 9's already a constant, so it's just 1 without x. I don't do it. A, B, C. Okay, 1 times 9 is 9, positive this time, so the signs have to match. Start with them both as negatives, and we're adding to try to get to negative 10. 1 and 9, add those, you're at negative 10. Boom. Now, pay attention to your A. You have to when doing this. A is 1x to the 4th. Now, you can get rid of your 1. If it's another number, you can't. You have to make 4 of them, okay? But since it's a 1, I can get rid of it. So I just need 2 parentheses, but it's x 4th this time. So I split that into half, okay? Minus 1, minus 9. Now, here I was done because they didn't have powers, but here they do have powers, so I bring them both over here and see if each one of them could be factored as adopts. Well, that's x, that's 1, 1, so definitely that can be. That's x, and always go plus minus, 3, 3. That definitely can be. Okay, then you go x, 1, 1. The minus, we don't put i's. If that's a plus 1, we do put i's. X, 3, 3. Okay, and that's how I'm going to get my 4 roots. Okay, so x plus 1 could equal 0. Minus 1, I get negative 1. The second parentheses, x minus 1 could equal 0. Plus 1, we get 1. X plus 3 could equal 0. You just minus 3, negative 3. And then x minus 3 equals 0, plus 3, positive 3. Okay? All those are roots. They're all real. There's no i's involved. They're all rational. There's no square roots. Okay? You can have i's. You can have square roots. I just didn't on that problem. Okay, number 9. Still factoring. The directions did not change. You've got 3 roots because of the 3rd power, but this time how many terms you got? You got 4. Now, it said find the roots by factoring. So to factor 4 terms, you go with your grouping. Parentheses plus parentheses, and then the lines parentheses plus line parentheses, and then big line parentheses, we just put a little one here, okay? And then after that final parentheses, you're going to want to see if you can do adopts from there. Okay, so first I take the 1x cubed, put it with the minus 7x second, then negative 9x plus 63. Okay, 1 and 7 would be 1, but they both have, but the final line has x to the second, so we're going to put x to the second. 9 and 63, if you use your multiplication table, you see 9 and 63 both in the 9th row. You're not going to put an X because that final line doesn't have X, but you are going to put a negative sign because you have a leading negative right there. So 1x seconds out, negative 9's out. And now these better match, okay? I wouldn't be telling you to factor if they didn't. So it's 1x minus 7. This is the same thing, 1x minus 7. So inside of those parentheses, I have the same thing. So I'm going to put that in the little parentheses, 1x minus 7, okay? And then I put the 1x second with the negative 9, but write 1x second plus minus 9, not plus negative. Now dots. When you're doing a dots, if you have a 1 in front of the x, ignore it. Well, that's xx, that's 3, 3. These do not need i's because we have a minus right there. Okay, so here's factor 1. That's how I get my first root, and then down here is factor 2 and factor 3. So 1x minus 7 equals 0. X plus 3 could equal 0, or x minus 3 could equal 0. So I add 7. That's 7 divided by 1 would still be 7. Negative 3. And positive 3. Okay. Now, number 10. Refer to your solutions for problem number 8. Here's problem number 8. Look at those solutions. Negative 1, 1, negative 3, and 3. Take the graph of that same equation. So instead of equals 0, it says equals y. Find the roots. So the roots are the answers you got. Negative 1, 1, negative 3, 3. How many of those roots would be x-intercepts? Oh, all of them, since none of them have i's. Okay, so just write them all down. If some of them have i's, you don't write those here. Because i's are not a real number. You don't cross the x. And the y-intercept is that number at the end. If I took all the x's out, y would equal 9. Okay? Didn't take hardly any time at all. Okay, number 11. Find the quotient and the remainder. Set up your L. Okay? This is to lead you into something else. I take all the coefficients in the front, 1, 3, negative 4. And then outside I take that x minus 1, quick set that equal to 0, somewhere down here. So I'm going to divide by 1. 1's my divider. So I drop that first one down. Then I take 1 times 1. That's 1, but don't put it here. You put it here so you can plus it to 3. 4. 4 times 1 is 4. Plus it. The remainder is 0. Okay? So I take that 1 that used to be x to the second, now it's just x, and then 4 is a constant. Now the 0 means it's not a remainder. That's the answer. Number 12, x to the third plus 7x to the second minus 5x minus 6 divided by x plus 2. Okay? So we have 1, 7, negative 5, negative 6. Remember, those have to be negatives. Take that x plus 2, set that equal to 0. That's negative 2. So I'm going to, negative 2 is my divisor. 1 times negative 2 is negative 2, then I add, that's 5. 5 times negative 2 is negative 10, then I add, that's negative 15. Times negative 2 is 30. Yeesh, I don't get 0, do I? 24. But that's okay, you're not finding the roots, okay? You're just writing the quotient. So that 1 used to be x third, not anymore. Now it's down to x second. Plus 5, x minus 15, that's a constant. Plus, and then I write 24, I underline 24, and I put that expression beneath it, x plus 2, whatever is in the second parentheses. That's your answer. That's just a remainder. Remainders at the end go over that expression you're dividing by. Okay, number 13. use the rational roots theorem to find the equations, the roots, the solutions, whatever you want to call them. So you have 3 to find. Don't try to do the grouping, it won't work. You go RRT, okay? You take the coefficient at the end, just put 2, don't worry about it being negative. And then you take your leading coefficient, 1. This is going to be a pretty short list. The only factors of 2 are 1 and 2. The only factor of 1 is 1. So basically my possibilities are just 1 and 2, but they could be negative, okay? Okay, we'll put 1s in front of these for later, and then we'll substitute those in. I got to get my first answer just by plugging it in. So 1, and 1 raised to the third minus 1, 1 to the second, minus 1, and then 1 minus 2. Okay, that didn't work. Now let's try 2. And this isn't a story problem, so we will switch to negatives if this 2 doesn't work here. Oh, 2 worked. Okay. Now to get my last 2 roots, I put the 2 out here, and I line these up. 1, negative 1, negative 1, negative 2. That's my first answer, so that's what I divide by. Drop the 1. 1 times 2 is 2. That's 1. 1 times 2 is 2. That's 1. 1 times 2 is 2. 0. So now that 1 that used to be x to the third is now 1x to the second plus 1x plus 1 equals 0. Now, this is where this comes into play. It's actually quite useful. 3 terms, I think maybe GCFT, but I'm going to try that to see if that's even worth the trouble. I go second, square root, double it when you do your calculator, and then b. b is 1. Actually, they're all 1, okay? Okay, if you get domain error, you're going to go to the quadratic formula, just like you would if it was an irrational number. Okay, so opposite of b, plus or minus the square root, b squared minus 4ac divided by 2a. Opposite of b, so it's going to be negative 1. b is 1. 4a is 1. c is 1. And a is 1. This helps tell me, do I need to even waste time with GCFT? So you got negative 1, 2 times 1 is 2. 1 times itself is 1. 4 times 1 times 1 is 4. And that gives me negative 3. That's why the calculator gave me a domain error, because it doesn't recognize square roots of negative numbers. So we bring the I out, and you just put I square root 3. And that accounts for your other 2 roots. You don't need to write that big of a thing down there, but there's 2 and there's 3. Mission accomplished. Okay, and then you have some little exponent expressions to simplify. 2x to the third to the second, and then 5x to the fourth to the second. No addition or subtraction operators, so we make our 3 lines. Number bases, you have 2 and 5, and then you have x, okay? So let's talk about the 2. Put a 1 with that 2, and it's in parentheses, so we distribute 1 to 2 is 2, so it's 2 to the second. 5, 1 times 2 is 2, 5 to the second. Now there's 2 x's, and they're both on top together, so that's multiplication. That means we add the powers, since they're on the same side of the line. 3 times 2 is 6. 4 times 2 is 8, that'd be 14. None of those powers are negative, so this is not needed. Now I can simplify 2 to the second, that's 4. And I can simplify 5 to the second, that's 25, and then times x to the 14th power. You want to multiply 25 and 4, that's 100. Okay, 100 times x to the 14th power, simplify. Okay. Make your line. You got a 2, an x, and a y. Pretty straightforward. 2 is to the 1, so I distribute 1 to negative 2. It's negative 2. X, 3 times negative 2 is negative 6. Y, 7 times negative 2 is negative 14. Guess what? All those are negative. All those powers are negative. You need to move them all to the bottom so you can rewrite them with positive exponents. Now cover the top with a 1, then we should never have an empty top. I can simplify that, so it's 1 over 4, and then on bottom x to the 6th, y to the 14th. Done. Okay, you got 12 and you got 4. So times x times y. I don't need to put x on bottom because it's already on top. Okay, these are both to the first power, and I don't need to distribute because there's no parentheses. They'll just both be to the first power. Now x, you got 2 of them, but this time they're divided. They're not multiplied like they are here. So instead of adding, we're going to minus. You just go 5 minus 3, that's 2. Then your y, you just have the third. None of these are negatives. Okay, we don't need that. Just keep everything where it's at. Nothing moves. But the 12 to the 1 becomes 12. 4 to the first becomes 4. Then x second, y 3. Now, here you ended up with the two big numbers side by side, so you multiplied them. When you end up with top and bottom, you go to your chart and see if 4 and 12 appear in the same row. They do, okay? So you need to divide those both by 4. So that becomes a 1, that becomes a 3. So 3x to the second, y to the third over 1. Story problems. Okay, a garden's width is 5 feet more than twice its width. Its area is 240 square feet. Find the dimensions of the garden. When they're talking about a shape, you're going to set this up equal to either the area or the volume, 240. This is area. Area is length times width, but we need to write that so we have the same variable. We use this is right here. W. Now put length on the other side. Twice the length, and then 5 more. So in the W parentheses, you put 2L plus 5, and W's gone. Okay, and then here we'll put L. Now we have the same letter, so now I distribute, or it's not really FOIL, but you can call it that. And then 1L times 5, so that's 2L to the second and 5L. Now you just got to find the roots. There's 2 of them for L. Okay, you got also have L to the first. You need to get that equal to 0. So you minus 240 minus 240. Okay. Now 3 terms. Let's decide if that's even worth it. Let's use that green sheet to see if I even need to waste time with the T-chart. Okay. Can easily see A, B, and C. Second square root, double it. 5 to the second minus 4, 2, and negative 240. Okay, that's irrational, so I go right to the quadratic formula. I'm not going to waste time with GCFT. Okay, so the opposite of B, that's going to be negative 5. Now, this crap here you can cross out. When you do that on the calculator, you can just get rid of it, okay? And you just write 44.10, not the square root either, okay? Square root's gone. I just punched it into the calculator, so 44.10. Then 2 times 2 is 4. That's the beauty of that, okay? So negative 5 plus 44.10, click equals and divide by 4, 9.78. That's a good looking answer. I mean, if you want to rewrite the whole thing, fine, but when you do that, that is what goes here. Not with a square root either. Square root's gone. Negative 12.28. Now, ditch the negative and forget it. 9.278 my length, and my width, I come up here. I replace that L with the 9.78, which enables me to find my width. 2 times 9.78 plus 5, 24.56. Now, if you multiply those, it's going to be pretty close to 240. Won't be exact because the square root of the quadratic formula was irrational. Okay, number 18. A cube's length is 3 units more than its height. The cube's width is 4 units more than its height. The volume is 20 cubic units. Find dimensions of the cube. Okay. Now they're talking volume. Now that's 3 dimensions. It's not as, remember, length, width, height. Use those is to write little equations. Length is, put your height, 3 units more is plus 3. You won't have a multiplier. Width, 4 units more than its height, so I write h plus 4. So in the length, I put h plus 3. In the width, I put h plus 4, and there I put h. All those say h. Now you're going to multiply this out. It's not as crappy as it seems, okay? Going to take FOIL the first two, 1h times 1h. 1h times 4, 3 times 1h, 3 times 4. So it's 1h to the second, 4h, 3h, and 12. Combine those, and that's 7h. So I write here 1h to the second plus 7h plus 12. But don't put that down here because you still have to multiply that all by h, which is easy to do. Everything just goes up a power. So 1h to the third plus 7h to the second plus 12h. Now you can go about solving it. There's 3 roots, but you just have to find one. You just have to find one that is a positive and a rational root. Well, we clear the 20. Remember, you always got to clear that. So you have the equal. To find roots, you need it equal to 0. And now go to your rational roots theorem. You got 20 and you got 1. So factors of 20, you got 1 and 20. So I'm not going to use quadratic formula, there's 3 terms. So instead I go to the rational roots theorem. 2 and 10, 3, 4 and 5, and then 1. Okay, plug all those into the calculator. You don't need to divide by 1. These are your possibilities. Let's try 1 to the power of 3 plus 7, and then 1 to the power of 2 plus 12, 1 minus 20. Oh, I got 0. That's a good one. You don't need to find those in. 1 works perfectly for my height. Now I just come up here. 1 plus 3 is 4. 1 plus 4 is 5. Multiply all of them, it's 20. And again, why would I need the other 2? The other 2 are going to be i's, they're going to be irrational, they're not going to make sense, so that's good enough. Okay, last problem. A company's profit can be modeled by the equation negative 5x to the third plus 6x to the second plus 15x. X is the number of items produced by the 1,000. Profit is $14,000 for producing 2,000 items. What other numbers of items produce the same profit? My camera's about to die, so if I click off, there'll be another video at the last problem. Okay, you're given an equation, write it. When they come up with the equation, you don't need to do anything to figure out how they got that. You just go with it, make a box here to define your variables. C or whatever's over there is your money. Money can't be X, and X is whatever you're selling. Here it just says items. Okay, now you're given a couple values. You're given 14 for C, and you're given 2 for X. Now place those into the equation at the same time. And then put 2's in for all your X's. Okay, now plug that in to make sure it equals 14. If it doesn't, something's off. You have something written down wrong. Equal to 14. Beautiful. Okay. Now I still want to keep that at 14, but I want to find other roots that can give you 14. Now there would be 3 roots, and guess what? You already have the first one. You don't have to apply the rational roots theorem. You just had 2 in for x, so you put 2. Now I set up my synthetic division, but you got to clear the 14, okay? All these story problems, you got to clear one side. So you got negative 5, 6, 15, negative 14. So I drop him times negative 5 times 2 is negative 10. Negative 4 times 2 is negative 8, plus 15 plus negative 8 is 7. 7 times 2 is 14. Beautiful. Now that used to be 5x to the third. Now it's x second x plus equals 0. Now I'm going to decide if the t-chart's even worth it. So I go to my square root. b, negative 4 second minus 4. A is negative 5 and C is 7. Okay, that's irrational, so I go to the quadratic formula right away. Again, if you get a whole number, maybe you want to do the t-chart. Okay, opposite of negative 4 is 4. Now you can plug all that in the square root, but you can really just get rid of your square root, actually, the entire thing, and just put what you got on your calculator, 12.49. And then A is negative 5. Now if you want to go about it the long way, be my guest. And don't put the square root over 12.49. I punched the square root in my calculator, so it's gone. Okay, and then from there. 4 plus 12.49 equals, divide by negative 10. Negative 1.65. We're going to write that down, but then we're going to take it out. Then 4 minus 12.49 divided by negative 10, 0.85. That's okay. Okay. Now, please label the right prefix. It said 2,000, so I want to see 1,000 right there. Bam. Okay. So again, story problems, 2 dimensions, length, width. Use those is. Okay. You got 3 terms. See if quadratic formula. L second L, quadratic formula. Test the discriminant. So that means if I get an irrational decimal, t-chart's a waste. Okay. 4 terms. Okay. 3 roots, 4 terms. Use your rational roots theorem. Okay. With the 20 and the 1, test them out. You just have to get the first one. This one, I already have 1 root, 2, so I just got to clear that and do the synthetic division to find the other 2. One of them's positive, so it makes sense.